Now that I've got the power latch circuit installed and working nicely, I want to go into a few code modifications that I now want to make. First one is to get the rear light to come back on at its last setting before it's switched off. This is only ever really meant to be an emergency backup or extra light. If I'm really out in the dark for a while, I will have an extra battery powered one, so it's just a backup. I chose to do it this way instead of save it just before the Arduino switches off. Basically, we've got the wait for input from the serial monitor. When the input comes in, we just write it to the EEPROM and then do the button presses as normal. And in the void setup, we read from the EEPROM and then do the button presses as shown in the previous piece of code. The only thing to note though is that it's advisable to write a position to the servo, because otherwise it can go to a random position when it's switched on. This is because this section of code here takes a little while to run, because every button press is at least 60 milliseconds, so you could have up to 60 times 7. So that just prevents the servo from going to a random place just after it's switched on. Another one is to get the Bluetooth module to keep it switched on. So at the moment the LED is flashing, but if I connect, stop flashing, and that will now prevent it from switching off. This is obviously useful if I'm logging data, because it'd be annoying if the Bluetooth gets disconnected. So to do this, I have to actually modify the Bluetooth module itself. It's an HC06, so it doesn't use these top and bottom pins. So what I've done, because I want to get the LED, which is here, the status of that, whether it's on or off, back to the Arduino, I've taken this piece of enameled copper wire from there round to here, because there's a resistor that was there which I've knocked off, and that is connected up to this pin here. So that should get the whether it's a high or a low on here to this pin and to the Arduino. Once that's done, we can read what the status of the LED is on the Bluetooth module. Now when the Bluetooth module is not connected, it will flash equally on and off. So because this is only running at every half a second, some of the times through the loop it will read as low and sometimes high. But when it does read low, it will enable the off timer to count up. Obviously the speed has to be 0 as well, but if the LED is on continuously when the Bluetooth module is actually connected, then the counter can't count up and it will just equal itself. Once it's counted up to 30, because now we're only going to be counting up on the low of the LED, so that's going to be half the times through the loop. So this here roughly represents seconds, even though the loop is running at half seconds. Another one is a program mode. So if I go into 5, all these values can now be changed, and they are stored in the EEPROM, so they will stay like that even when it's switched off and back on again. Initially I set all these to 0, so these are values like for the derailleur, the ratio, offsets, shift slope, things like that, end stops of the servo, PID, and for the power equation. So that's all initialized at 0, and then further on down here we get them all from the EEPROM during the void setup part of the code. So they are then all loaded up from the EEPROM. One thing to be really careful of is allocating the number of bytes in the EEPROM for each value. Now these ones are stored as a byte, so they only take up one space. A lot of the rest of these here are integers, so they only take up 2 bytes. But these ones here are floats, and so they take up 4. And again, these some of these are also bytes, so that's only 1. So that's really important to get that right, otherwise you'll read nonsense values. Now to change the values, you can do it through the serial monitor or connected through Bluetooth. I've created this I call like a program mode, and this is basically, to start with, we're printing all the values onto the serial monitor and then waiting for an input. Now the input then selects one of these, so let's take an example of the shift slope. So it just asks to enter value, wait for an input, and then we process that input into an integer, write it to the EEPROM, and then verify that's done, and then it just prints this again. And then to exit, you just enter a 13 and it jumps back out of that and goes into the main code. So there's quite a lot of code to write for that. It's quite long, but it does mean that I can change the values on the go, and they are then saved into the EEPROM. And the final code modification, just a little addition. It's helpful for the setup of the hub. If I go into 8, and now this means that I can use the handlebar buttons to manually move the servo, and the value is displayed on the serial monitor. You can also type a value in as well. So if I put in 30, goes to 30, and so you can use that to find the end stops on the hub and just wait for the cable to go tight, and then you know you've hit the end stop, and make a note of the number on here, and that's then programmed in to the previous setting mode as I showed you, either on the laptop or using the Bluetooth. So this is mode 8, and first we print the instructions to the serial monitor, and while there's no data coming in from the serial monitor, we just keep an eye on the buttons. Now the button counter, that comes directly from the 1 kHz interrupt, and so the button has to be pressed for greater than 50 milliseconds for it to count as a button press. When it does, we increment or decrement the servo position, write it to the servo and the serial monitor, so we can just check what that value is. But you can also write a value to the serial monitor and it gets picked up here, converted to an integer. Now if that value is greater than 0, we write it to the servo and back to the serial monitor. But if it's less than 0, we use this as a way of exiting out of mode 8. So we just return to mode 3. Now that sums up the 4 modifications that I made to this code that I wanted to share, and that's it for this video. Thank you for watching.